So just have a look when we're going through this, and then you can fill in your perfect squares, not perfect squares afterwards. So a perfect square is a number that the same number multiplies itself to get that number. So if I'm looking through this, 1 is an example of a perfect square because 1 is 1 times 1. So 1 is 1 times 1. So because you've got the exact same number multiplying itself, it's considered a perfect square. So if we think of 50, 50 is 1 times 50, 2 times 25, 5 times 10, 15 doesn't go into it, 12, 5 times 10, 50. I think that's it. There's not a number that multiplies by itself to get 50. 101. 10 times 10 is 100. That's as close as we can get. There's no other combo of numbers that's going to get, because 11 times 11 is 121, and 9 times 9 is 81. So this is not a perfect square. We just said 9 times 9, 81. 5 times 5, 25. 11 times 11, 121. 7 times 7, 49. 2 times 1, 10 times 10, 8 times 8. This is 6 times 6. Ooh. 2 times 11. 2 times 5. Oh, what's 100 times 100? I think it's bigger than that. No, it is. Oh, yeah, it's bigger than that. 1,000 is 100 times 10, but 100 times 100 is 10,000. So this is not a perfect square rootable number. Okay, so that gives you an idea. These numbers can all be broken down into the exact same number multiplied by itself. These ones can't. So you have to be really good at recognizing these. And on our next page, I've got a little bit of a helper here. So you have to recognize a question that is a difference of squares. It's going to have a perfect square rootable number right at the beginning, and it's going to have a perfect square rootable number right at the end. And that one of those, it's 1, 4, 9, 16, 25, 36, 49. Let's fill these in. I need a calculator halfway down, even though I should have them memorized. Clear. Okay. 3 times 3, 9. 7 times 7, 49. 15 times 15 is 225. Ah! How do I get out of that? 15 times 15. 225. Yay! So those numbers, don't have them memorized, but I mean, up to 10 you should have, maybe even up to 12. I've got up to 12 memorized. Once I get to the 13, 14, 15s, I start to get a little bit hazy. But I think you should definitely have up to 12 memorized. So we have to recognize, looking at this, yes, it's got an x squared at the beginning. Yes, it's got a minus in the middle. Yes, it's got a perfect square rootable number. So the way I would solve this is I would set up a positive bracket. I'd set up a negative bracket, and then I have to get the exact same number by taking the square root of 49. That gives me a 7 and a 7. They've got to be identical numbers. Okay, I can't put a 6 here and an 8 there. They have to be the same number. Okay, the only thing that's different is one of the brackets is positive and the other one is negative. Oh no, there were more. 25. 25 squared is 625. I know that one. 25 squared is 625. What's 22 squared? 848. Cool. Okay. Let's look at this one. 4. Yes, it's in this list. It's a 2 times 2. Good. Negative in the middle, awesome. 9, yes, it's in the list. It's 3 times 3. So, because the 4 is at the beginning, we're going to take the square root of the 4 and then take the square root of the 9. And the 4 is in front of the x squared, so we're going to take the square root. So it would be a 2x and a 2x. The numbers have to be identical. X times x gives you the x squared. One's going to be positive, one's going to be negative. Square root of 9, 3 and 3. So notice, everything's the same except one's a positive, one's a negative. This one's not as bad because we only have the number 1 in front, so we don't have to worry about it. Square root of 100 is 10, x plus 10, x minus 10. Okay. Square root of 16, x squared. That's a 4x and a 4x. Square root of 25 is a 5 and a 5. One's positive, one's negative. Last one, square root of x squared, x, x. Square root of 144, 12, 12. One's positive, one's negative. How are we feeling about that? So I'm going to make this a little bit longer of a video. You have to be able to recognize when you've got a difference of squares and when you don't have a difference of squares. And this is the only really tough aspect about these types of questions. The ones where you've got 3 pieces, you do your product sum tree, you find the 2 numbers that multiply and add to give you whatever, and life is good. You create your 2 different brackets. But with a difference of squares, you're creating brackets that are almost identical, except one is positive and one is negative. So when I'm looking at this, I'm saying, okay, I can take the square root of x squared. There's a negative in the middle. And I can take the square root of 81. This is a difference of squares. Can take square root and there is a negative. Okay, next question. I can take a square root. There's a positive. Nope. I can take a square root. This is what's stopping us. Not difference of squares. There is a positive. Okay. I can take the square root. There's a negative. I cannot take the square root of 20. 4 times 4 is 16, 5 times 5 is 25. This is not a perfect square rootable number. Not difference of squares. Can't square root 20. Okay. Okay, square root of x squared. Yes, it's a negative. Yes. I don't know if this works. That's not something I have memorized, so I'm actually going to check it on my calculator. What is the square root of 196? Ooh, 14. That works. This is a difference of squares. Everything works. We can take the square root of 9 and x squared. There's a negative. Can we take the square root of 16? Yes, difference of squares. Everything lines up. And the last one, we can take the square root of x squared. Nope. And then you can take the square root of 4. Not. Difference of squares can't be positive. Has to be a negative number. Good.